Hello, everyone. Good afternoon. Thank you for joining me wherever you are. Welcome to yet another hands-on coding session. This will be our 7th for the series in this Hammer Data Science Summer 2022 cohort. I apologize for starting a little bit behind schedule, so apologies for that. Anyways, what we have to do will be an interesting session. It will be relating more to the data engineering / MLOps track. So just sit back and relax and enjoy. With me, I have Arinze, who is a junior data engineer in Hammer AI Labs. So we'll be the one taking us on today's session. So without wasting time, I'll just introduce him. Arinze, you have the floor. Arinze, okay.
Okay. Good afternoon, interns. Welcome to today's section. So for today, we'll be discussing on kubeflow pipelines and components. So let's get started immediately. I have just an hour, as I was told. Okay. Hope you can see my screen. Is it clear enough?
Yeah, we can see it. Yeah, we can see it.
Okay, good. So for this program, this live coding section, we'll have 3 segments for our program. The first segment will be on Docker at the workflow. What is Docker image? We'll look at it, how to build a Docker image, some basic commands in Docker. We'll take a demonstration in building and deploying a Docker image to the Docker Hub repository in the first segment. In our second segment, we'll talk about what a pipeline is, concepts in kubeflow pipelines, then ways of building kubeflow pipelines and pipeline components, basically going through the reusable components and then the lightweight components. And in our very last segment, we'll take a demonstration on how to build components using reusable technique and also using the lightweight component. So to segment 1 now, what's a Docker image? A Docker image is a file used to execute code in a Docker container. A container is a standard unit of software that packages up a code and all its dependencies. So the application runs quickly, reliably from one computing environment to another. Now, a Docker image can be seen as, let me say, as a container that houses a particular ML project or a particular step in an ML project. That's what a Docker container is. And generally in MLOps, what we do is that we try to containerize all our applications. Like let's take, for example, you have, let's say, an ML project based on classification. The workflow and the standard is, in that project, we'll try to break down each component or each stage of an ML workflow into stages. Like we can have the data loading phase, data preprocessing phase, the model building phase, the model training phase, the model testing phase, and then the model evaluation phase. Now, in these different stages or phases, what we do is that we try to put each stage into a container image. Now, such that anyone that has that container image using any operating system can always run our codes comfortably without having any need to, like, say, maybe change your OS you are using, maybe from Windows or to Ubuntu or to MacBook. So with Docker affords us the opportunity to have our code running on any platform as far as that code has been Dockerized. And now, after building an image, what do we do normally as data engineers or as MLOps engineer, we push this, our Docker image into a repository. Now, this repository is where houses the code we've prepared as a Docker image. So I'll demonstrate to you now, in the very first segment, how do we build the image and how do we deploy this image into the Docker repository. Now, I've given an outline of the steps. The very first step is to write the Python script. Now, definitely, the Python script should be able to answer a particular question or a particular application you want to run. That is one. Then two, you write the Docker file. Now, a Docker file is like a declarative section where you put all the dependencies that will be required to run the Python scripts. After that, what do we do next? We get this Docker file and our Python scripts into a directory. Now, this directory, if in the directory now, we'll now build the image and then also deploy to the repository. But definitely, for us to run Docker, we need Docker to be running in our machine, be it local or on the VM, the virtual machine. Yeah, for this section, I'll be working with both the local and the VM, so you can see how we work in the MLOps feed in a way. So the basic steps we have is first is to build the image by running Docker build tag image name, then Docker run image name, Docker tag image name / repository name / image name, and then Docker push. So let's go straight away to my notebook already. I've cloned the notebook to my VM, so I will work from my VM currently here for this live coding section. So let me do that now. Go to my command line. Okay. Okay. Let's get to the VM and begin properly. So I already prepared 2 examples we'll be working with for this Docker demonstration. Let me get to the GitHub. Yeah, there's my GitHub. Okay, I have Python script for Docker. So you can always get to my repository to get everything we'll do today. And on your own, try to maybe practice it on your own. So a very first example we'll run now from the Docker building and pushing to Docker Hub. So this is the VM up and running now. Okay. So I have CD. Okay, yes. See what I have here. Okay. Okay. ls. Okay, reusable. ls. Let me clone the repository then. because we'll have to get the Python script and the Docker image. I'll show you how that was prepared, and we'll run it and build, and also push to the repository. Let me clone the repository now. I hope you can see my screen very well. Hope it's clear enough.
We can only see your repo. We can't see where you're writing your code. So that's a virtual machine.
Wow.
So I guess you have to split it so we'll see.
Okay, I'm coming then.
On screen, yeah.
You can see this one now, right?
No, still your repo for now.
Okay, I'm coming. I haven't signed in. Stop share. Let me see. How about now?
Not yet.
What?
Not yet.
Not yet.
Yeah.
Wow. Okay, I'm coming. Yes, correct. Is it up now?
Yes, it's up.
Okay. Let me clone the repository, please. Give me some minutes. Let me get that done. Asking for my verification for GitHub. Wow. I'm coming. Wow.
We can see your command prompt now.
Command prompt.
Yes, and your VS Code.
Okay, let me Let me create a folder now then.
All right.
Okay, no problem. Let me do this. So I'll just write a Python script now, and then we'll run it immediately. Maybe an easy one. Let's say hello. Yeah, welcome to Docker. Document. Just taking time to come up. This is taking time. Let me try this then. Okay, while that is still coming up, the VS Code, then let's take that off. Okay, it's up now. Okay. Wow. This is ls. Okay. That's taking time to come up. Let's take the next segment. I'll come back to the demonstration for the Docker file. Then let's take the kubeflow. Don't know what's taking time to. I don't know what's taking time to clone this. Git clone. Okay, beautiful. Okay. ls. So I have cd live coding section. ls. Then cd Python script for Docker. Let's see the content of that folder. So I have two examples here. Let me go to the first example, cd example. Example 1, ls. Okay, I have, so let's see the content of the Python script now. So let me do vim hello.py. Okay, now what I've on that script is just telling us to print hello, welcome to Docker. That's what I want the script. Okay, so let's see the Docker file for the work then. So let's read the Docker file, vim Docker file. So now, in writing a Docker file, the basic, let's say, declarative you need to show in your Docker file. One is definitely the work. What is the file type of that work? Is it a Python script? Is it maybe a Node.js script or so? But for this exercise, we'll be using Python. And the Python version I picked to use is Python 3.10.4 Slim Buster. Now, the work directory you have over there, hope you can see my screen, right?
Yes, we can see your
See my screen?
Yes,
okay.
you can.
Now, the work directory is like a directory that'll be created in the Docker image that'll be formed, Docker container. So in our container now, we have a directory that'll be titled app, then environment. If you want to port this your work maybe on a local host, what port do we use? So I use the port 80. Then we have a copy, because then to have this work run on a Docker on a container, you have to copy the Python script from your local, from your VM to the app. That's what we have now, hello.py, which is our Python we saw earlier, .app. Then the next copy now is telling us, okay, in my container, please, from this Python script, take everything in where I have hello.py into my app. That's what that second copy stands for. Take all the content from hello.py and save it into the app directory on our container. And then we have the command. Now the command tells us, okay, now this work you're trying to build or trying to deploy to the repository, what command should we use to run that application? Now, because our work here was prepared using Python, the command there has Python, and then the file name, which is now hello.py. So this is the Docker file. Normally, you have to have the Docker file and the Python script in the repository where you want to build your Docker image. So let's build our Docker image now. Okay. Now, the very first step in building an image is to run the Docker command, which is docker build. So I have now. Okay, but first, we can still verify if the script is functional by trying to run the script using normal Python. Let's try that now. Let's confirm that the script we have is okay. So to test my script, I'll do Python 3. Then my Python script I have, which is hello.py. So let's do this. You see now, it gave me hello, welcome to Docker. That means that this script is functional and is working. Let's build our image then right away. Docker build. -- tag. Then the image name, let's call it hello Docker. Hello. Okay, it's enter key. Okay, I need to go to my sudo root. So I have Docker build dash tag. Our name will pick hello Docker. A space, a full stop, and then sending build. Okay. You can see now it copied the work from our Docker file, just command we ran from work directory, environment, and the rest of them. So the next step now is to do Docker run. Docker run with our name we picked earlier, which is hello Docker. Okay, it printed for us, hello, welcome to Docker. Okay, let's tag our image. So we have Docker tag. We'll pick the image name we'll use there, which is hello Docker. And then you have to also, at this point, you have to write your repository name, which I'll do now using my own Arinze02. Then slash the name we picked now, hello Docker. Then we run it. That has been done. The next, after doing Docker tag, then we can do Docker push. Docker push. For Docker push, you require your repository name, which in this case is Arinze02 slash the image name, which is now hello Docker. And then we do this. You see now, it's now building the images for this container we have now. So now to view, now to confirm if this has been done, we can do Docker images. Let's see if what we did now has been sent to the Docker repository. Docker images. So we have now, you can see now here, Arinze02 slash hello Docker, created 2 minutes ago. Now, this is one way of building and pushing an image to the repository. There's another technique also in doing the same thing, but that will take a much longer time. So let us go back to our workflow to see. So now we've done Docker build, we've done Docker run, we've done Docker tag, we've done Docker push, which we've seen now. So the next thing here is to see some basic commands in Docker. Now, if we run Docker PS, what does PS stand for? What is PS? Now, the PS there stands for process. Now, if we do a Docker PS-A, it will list for you all images that have been built on that particular repository. If you do Docker RM, that RM there stands for remove. Now, let's assume that you want to remove an image. Okay, let's do it right away. Let's go back to the VM, our CLI. Let's do Docker PS. Docker PS as processes /A all. Now, what you have now are what the works I've done on this my Docker repository. All this we are all built. Yeah. One we did just now is what you can find at the very top. Hello Docker. Let's assume you want to remove that image now. I said to remove image, you do. Let me minimize this. I can have enough better view. So let's do Docker remove. Docker, that is Docker RM. Then we have our image name, hello Docker. I'm coming. Docker, let me use the image ID now. Docker RMI. Let me copy the image ID here. Image ID. Control copy. Okay, see now we've untagged it and that's been removed from our repository now, which is the one we just built now. We can also run some more commands. Okay, already we've seen Docker build, we've seen Docker run, we've seen Docker tag, Docker push, then Docker pull. Now to pull means to remove an image from a repository. That's for the Docker pull. So currently now I've removed my image, so it's no more there now. So I removed it. And now these steps are what we will do iteratively when we come to building kubeflow pipeline and components. Because in building pipeline and component, which is our second segment, yeah. Now, a pipeline we know very well, we said, is a description for machine learning workflow. Oh, sorry. Workflow, including all of the components in the workflow and how they combine to form a graph. Now, a kubeflow pipeline is a platform for building and deploying portable, scalable machine learning ML workflow based on Docker containers. And that was why I felt the need to first illustrate how to build a Docker image and then push to the repository. Because those steps I ran earlier in building Docker image, we'll do it repetitively when building our kubeflow pipeline components. Now, there's some basic concepts in kubeflow, which we'll just discuss briefly. We'll go to our demonstration then. Well, a pipeline component, this is a self-contained set of codes that perform one step in the ML workflow pipeline, such as data pre-processing, data transformation, model training, and so on. It represents a step in the workflow where each component takes one or more inputs and produces one or more outputs. That's a graph. Now, a graph is a pictorial representation in kubeflow pipeline UI for the runtime execution of a pipeline. Now, for this graph, now after we finish building our pipeline, I will show you the graph we'll get from that work we'll do now in a few minutes time. We have experiment. So this is a workspace where different configurations of pipeline can be tried. It is usually used to organize runs into logical group. We have a step. Now, a step is an execution of one of the components in the pipeline. We can liken a step to be, let's say, data downloading can be just a step, or data pre-processing can just be a step. Okay. Now, in building pipeline components, we have two basic techniques in doing that. We can either build a pipeline component that is reusable. In such a case now, in that case, it is quite heavy because in such a procedure, we have to build a Docker image for each component in the pipeline. Normally, it's heavy, it takes time, but we run it here also, definitely. We run the work here. And the second procedure is going through a lightweight. For lightweight component, you require just your Jupyter notebook to run. But for this illustration, we'll run both techniques, that is the reusable and also the lightweight components, definitely. Now, in building a lightweight reusable component, what are the procedures? What steps do we follow to do that? Let's assume now, okay, like the work I have on the GitHub is actually a project to classify patients if they are diabetic or not, with about four classes. Now, for sure, for every ML project, we have different segments and stages. Now, based on the work I have here, I have 5 stages. I have the very first stage to be data loading. Then I have data pre-processing, data modeling, data testing, and model evaluation. These are the steps we'll take. So now we'll have to write a Python script for each stage. Are you with me now? So we'll write a Python script for each stage, and then also create a Docker file for each stage also. And we'll have to copy the Docker file and the Python script for each stage to a repository or to a directory. We'll do the same also for the data pre-processing, data modeling, and the other stages. We'll build the Python script, also build the Docker file. Okay, let me just go to my Jupyter notebook now. So we'll see what the entire workflow looks like. Hope you can see this, the notebook. Is it visible enough?
Yes, it's clear, we can see.
Okay, good. Okay, now, in the very first stage, we have creating the content of the data loading script. Import OS, import RGPass, import pandas, import Pico, and then the Python script. In this very first stage, our target is just to get the data for our work on our image. And that data set was posted on my repository, which you have here as the link. Yeah, young prof, kubeflow test, main project diabetes, and the rest of them, data loading. So this is the link to the data sets. And because we attempt to build a script that will be run on kubeflow or on Docker, we have to see how we can pass data from one component to another. Because running the script now on Jupyter will just work normally without having hitches. But we can't do that in Docker. We have to have a technique that will assist us to push maybe our output from a particular stage to the input of another stage. And that was why I had to use Pico. You saw earlier I had import Pico. Now with Pico, I can save the output of my file to a Pico file, which I named here as data PKL. So now it means that if I run this now, that means I will save this entire script, this entire work now to a Pico file named data.pkl. So I prefer we just go to the VM and let's work from there. Yeah, at the CLI. Already I've cloned. Okay, let me CD. Okay, let me clear this. CD. Okay, I have CD kubeflow. Is that capital K or what? What's the problem? Coming. Let me restart this VM again, please. Let me close. I don't know why this is not picking now. Let me close this and start from beginning. CMD. Come up. Come up. SSH. Okay, now if you can see this now, you observe I have data loading, data modeling, data pre-processing, model evaluation, model testing. Okay, let's view the script I have here for data. The very first stage, data loading. So let's see the content of that folder. I have now Dockerfile, data loading.py, data set requirement test file. Okay, let's view the script now. Vim data. Okay, just what you saw earlier on the Jupyter notebook, the same thing still. We have reading from the address there, then saving this file to as a pico file as data.pico. Okay, let's view this image immediately. Excuse. What did I do? Need to do sudo. Go to my root directory. Okay. Docker build. So I will target data. Okay, sorry. Dash tag. Data download. Sorry, that's the data loading, that's defining. Okay. So the next command is see do docker run data loading. Okay, that has been executed. The next I'll do is to Docker tag. So I have data loading. Then repository name as usual, arrange the 02/ the name of the image I have here, data loading. That has been tagged successfully. Then the next is to push to the repository, Docker push arrange 02/. Okay. Let's verify that that image has been sent there. Let's see, Docker image. Okay, a minute ago, we have it now. Yeah, we have arranged the data loading a minute ago. So let's take the next component now. The next component in my workflow is data preprocessing. So let's go to let's see the content of the file. So I have that for sure. I have the Docker file. I have data preprocessing.py. So let's view our Python scripts. So over here, I have defined data preprocessing. For sure, we have to take in our data set from the very first stage, which is data loading stage, by importing the data.pq, which we saved earlier in the very first stage. Then in preprocessing, what I did here was just to get our target feature and our dependent variable. So S for sure is our independent variable. Y is our target variable. And because my target variable in the data set earlier, a feature there was gender, which I tried to label in code, gender and also class, which I did there. And then I have to split the data set into train and test, which I did with this line of code here. S train, Y test, Y train, Y test equals train test splits, S, Y is our test size and a random state. Then for feature scaling, I had to use a min-max scaler to standardize the data set, which I did here. And I saved by the train data, the S train and Y train as train data.pq, this kind of code you have here. And also I saved the Y test and Y and S test and Y test as test data.pq. So let's save this then. Yeah. Okay. I wanted to run this on VS Code, but VS Code is speaking now. So let's work with the CLI for now. So let's run this Python script first to make sure it is working, because that is the only way we can confirm that the script prepared is functional. So I have okay, means it's working very, very well. Okay, so we cannot build our image now. Okay, let's view our Docker file for this one. Okay, for the Docker file, I have for sure my base image, which is Python, my directory in our container, which is app. Then things to install to run the image, we need pandas, we need sklearn, then numpy. And now I have to import the dataset that was saved in the very first stage, which is our data.pickle, which you have here. So I'm copying data.pickle into this directory, app. And also I'm copying the Python script, which is data pre-processing, into app also. And I'll take those two files to my app in my container, which you have here. So basically we need just to get the base image, which is Python, the directory, the modules to install, which is now pandas, sklearn, and numpy. Then the files we require to run this building, the data set, which is data.pickle, and our Python script, which is this now. So let's build the images for this also. Okay. Because in building reusable components, we have to build an image for each of the stages. And that is why most times it is very heavy and stressful. Docker build -- tag data pre-process. Okay. Okay, let's run it. Docker run data pre-process. Okay, that has been done successfully. Okay, let's tag it then. Docker tag data pre-process, repository name, image name, pre. Okay, let's push this to the repository. Okay, sorry, I named first repository. 02/ data pre-process. Okay. So we've sent our image for data pre-processing. Let's go for the next stage. Let's be data modeling. So go back to the directory, cd data modeling. Okay, let's see. Okay, ls first. So I have here Docker file as usual, then data modeling.py. Let's go to the Python script. Vim data modeling. Okay, now, so I have to import using pickle-t the output from the very second stage data pre-processing, which is our train data.pickle, which I got from this stage from second stage, and then I had to bring in my models. So I'm using 3 models for this work. statistic regression, support vector machine, and k-nearest neighbor to help us classify if a patient is diabetic based on the classes given. And then I will save the training done by this model into Pico files. So I have here, I have for regression, I have LR model.pico. I have for SVM also, and for k-nearest neighbor. So I'll save each Pico file for each model. Okay, let's do that right away then. Okay, let's see our Docker file for that stage also. So here, what I have here is just, as usual, my base image, which is from base image from the app in my container. Then I'm copying my train data.pico, then my Python scripts, and I'll take these two to my app, which is on my, okay. I can save this also now. Okay, let's view this image then for data modeling. Dash tag data modeling. Okay, I've done that. Okay, so let's, as usual, run. Okay, then I have Docker tag. Yeah, what you have here, because I didn't vectorize my train. Right, yeah, seeing this output telling me to vectorize it next time. Yeah, but I can tag this now immediately. Data modeling repository name. So I can push this to the repository. So I have, let's go to the next stage, which is model testing. CD. then ls. So I have model, let's vim model testing .py. So I have to import my test data, which is as Pico file, and the models we built earlier in third stage, which is the regression model, the SVM model, and the KNN model. And I run my prediction by running this model on the test data set now. Let me save this. So build this image immediately. Docker build. Model tests. Copy it. So I'll just tag this immediately. So I can have more time to run the pipeline. Docker tag. The name it there. I named it model test. Okay. Model test. Sorry. Then repository name. Okay, let's push this then. Docker push. I hope you're following what I'm doing. So, okay, then the very last stage now, which is for model evaluation. Let's go to that repository and view the image also. And I have cd ls. So I have, okay, vim. Okay, for the evaluation, we will getting the evaluation report for our work and also the confusion matrix are the two things we'll be looking at to see how good our model has trained. Okay, let's save this then. Docker build. So I have here tag model evaluation. Okay, so Docker tag model evaluation. Arrays 02 slash model evaluation. Then Docker push. Okay, since we've done this now, we'll build images for all our stages. We can move to our notebook now on Jupyter, and then let's continue from there. Okay, so we built our images for the very 5 stages. Now, after building a Docker image, the next step in this is to now turn these functions into a container operand using DSL, which we will do now based on what we built earlier on Docker. Let's go do that now. Okay, model evaluation. Okay, let me just run Center Notebook. Or should I just show it first here? So what do we do now? So now here we'll declare, because for this work to run on kubeflow, we have to convert our function into a container operand. Now this is what kubeflow understands. We have to convert our functions into a DSL operand that the kubeflow can actually understand to maybe read the content of our code and then get our output. So we declare for the 5 stages: data download operand, data preprocessing operand, model train operand, model test operand, and then model evaluation operand. So what do we put into our operand? Those images we built earlier, we'll not put their names now as our image here. So we'll write those names as our image, and then the command we use for our Docker file here, for the first one we built earlier, we worked with Python, and then data loading.py down to the very last, which we have here now, DSL for arranger/model evaluation latest Python and as a command, and then the model evaluation.py as a script. So after getting our container operand all defined for the 5 stages, we then write our pipeline. Now in that pipeline now, we'll arrange how the workflow should be, starting from the very first operand that we built, which is now the data download operand. So we have now data download task. I have data download operand and the volume which I'm to use for the work, which is my PVC persistent volume claim, which you see very well in Kubernetes. This allows us to access a particular volume in Kubernetes. So now we have data download task, which will work with the data download operand. We have data preprocessing task, which will work with data preprocessing operand. And this will only come after we've gotten the very first operand, which is now the data download task, which is this very first one here, where my pointer is now. And the next is our model training, this is our model train operand, and this should come after our pre-processing task. It's like a stages we are following now to get our pipeline, and down to the very last, which is model evaluation. So we'll have model evaluation operand, and we'll have our model testing task. Then after getting this pipeline, we have to convert this pipeline into a YAML file, because what kubeflow understands is just a YAML file that will have all these things we've done from our very first script we wrote down to the very last. So all this will be captured in the YAML file, which we'll output now. So let me just run this entire notebook so I can get YAML file ready. And then we'll move over to kubeflow immediately. Start and run all. Okay. Let's get this to run. Okay, you will get the GitHub. Okay, you get it. Let me type it now in chat. Let me just copy the repository immediately. I hope I've done test my repository this thing again, sir. This for my kubeflow. Let me get my kubeflow running also. Yeah. So that's where we'll have to. Okay, I can share this with you now on chat. Oh, sorry. Okay, I've done that. Okay, let's get to our kubeflow now. Connecting to Kanye. Okay, let's get kubeflow running. Oh, wow. Means I can't take the other one. This is taking time. I don't know why. Please let my kubeflow come up, please. Then we'll just test this YAML file immediately. Let's see how we can get. Okay. So kubeflow. Allow this to pick so we can just upload the YAML file then get it run. This is quite heavy. Let this come up the kubeflow, then we'll just attach the YAML file. No, experiment. Okay, let's create an experiment. Create experiment. So let's start this now. Diabetes classification. Let's call this Okay, let's change the name. Project. So let me get the YAML file that was created. Let me upload it now. And then we'll try to see the workflow. Let me rename that file. It already exists here. Let me rename that file. It's like I've used that name earlier. So, okay, back to our kubeflow then. Upload. Pipeline version. Is this pipeline version? Run name, let's call it diabetes test. Service account, pipeline runner, start. Okay. So it will build for each image from the very first stage, yeah, down to the very last. Okay. Okay, second one has been built. So the next one. Normally, this techniques normally is very heavy, so it takes time to run. Okay. The third stage now, model training. So what you can see now is a graph. I told you that a graph is actually a pictorial representation of the workflow in an ML project. Now we have these stages in our projects: ingest data, process data, train data. So the train data is the one that is coupling now. Okay. The next is model testing. So let's see if we can view any log. Okay, from train. Okay, that thing we got earlier, where we running the Docker. Okay. So when the last step now, model evaluation. Normally, building reusable components, surely it's heavy and it takes time. But in building lightweight components, that one you require just your Jupyter notebook for lightweight. So the stress of going to your CLI to build Docker images doesn't exist in this case now. You just write your script on notebook and then convert each step into a kubeflow pipeline. There's a module for convert. Okay, we are done. Let's see our logs now from model evaluation. Okay, beautiful now. So we can see our report now. So for statistic regression, we have an accuracy of 0.96. Then for SVM, we have an accuracy value of 97%. But for k-nearest neighbor, we have accuracy value of 93%. Now this is now the pipeline we've gotten for the project on diabetes, which we did earlier, from our Docker images to converting it into a container operand using the DSL, and then converting it into a DSL pipeline, and then creating a YAML file too, which we ran just now to get this workflow. Now, this is just one procedure in building a kubeflow pipeline. Now, the second procedure, which I will just explain without running anything here. Let me go to the notebook that has that. So it's called lightweight components. Now, in lightweight components, we don't build Docker images here. We just define our functions like now. But now, take note now that in building for lightweight components, every line of code has to be under the function. Like okay, let's compare what I have here for reusable. If you observe now, in this case, my importing was done before my function for reusable. But for lightweight, all the imports has to be done. All the import has to be done under your function and not before the function. And that is why you have this now, import OS, ArchPass, Pico, and the rest of them. So once you just run this Python script, kubeflow gives us a leverage to convert our Python scripts into kubeflow components. And that mode is kfp.components.create component from function. So with this module, we can convert our Python scripts into a kubeflow component. Now, you can declare a base image to use in this technique. If you observed earlier, we built our images when using reusable component technique. But for lightweight, you can just name a base image from Python and then add it up now as a base image and then run your notebook. And if after doing that, as usual, you have to declare also the DSL pipeline, which we saw earlier while we ran the reusable components, declare the pipeline also for this, as usual, obtain data, then pre-process task, model train task, model test task, and model evaluation task. And after this also, you combine all these things into a YAML file, which I named here, diabetic prediction pvc.yaml. So we'll not run this pipeline now, I've taken beyond the time given to me. So, but generally, the workflow in building component first is to have your Python script written as functions. If you're following the technique for reusable components, you have your Python script, you have your Docker file in a directory, you build a Docker image for each component. After doing that, you convert your Python script into a container operand using the DSL. After converting each component into a container operand, you will now arrange these container operands now as into a DSL pipeline, which we did here also into a pipeline. Now in this pipeline, after combining the component into a pipeline, we then create a YAML file from the pipeline that was arranged in the DSL. Now it is that YAML file. We'll now go to our kubeflow, to attach and create an experiment. Remember earlier, I had to create an experiment here. I did create an experiment here. From there, we have to go to upload our pipeline, which we did. After uploading the pipeline, which is this one here now, we did our run. What's that our run name self? It's coming up. Diabetes test. After doing our run, then we viewed our output from the pipeline that was created. So I'll suggest that since this is your very last stage in the internship and you're working on kubeflow pipelines and components, you can try to enroll on Azure. Azure gives you a leverage to have a VM, and in your VM, you can build your pipeline and component. And definitely with that VM, you can install your kubeflow, because kubeflow requires a minimum of 12 gig RAM to run on local, of which I know very, very well. I don't think in a way we can have that as a personal system for now. But if you do, you can actually install kubeflow on your local and try to run this pipeline. You can just clone the repository and try it out also. If you have any difficulty or challenge, you can always get back to me. I'll be willing to assist you in doing this. So I wish you the very best in your program. As you come to the end of your internship with Hamoye, try to maximize these 4 months you've stayed with them by doing these things on your own and getting the experience, because this will assist you when you come to the world, in the IT world, because these experiences are what companies sought out for to employ. So any question, you can take questions now regarding what we've done for today. Okay.
Okay, thank you very much, Arize. That was That was a very interesting presentation, breathtaking. Guessing everybody has questions, so this is a lot of time, but we should have time for like 2 questions. So if you have a question, you know how we do. Just signify by using the hand emoji, then I'll ask you to unmute, then you ask a question. Any question? I know it was very simplified. The processes you listed them out. It was interesting, and also I'm guessing we already got a good understanding of what he has been doing so far. So, but in case you still have questions, you can just drop, and he'll be willing to answer you.
Okay, stay there. You can still look at Aricto. Aricto give, like say, their newbies about 2 weeks to explore kubeflow in their website. You can try that also, and maybe try this notebook on their own website and see what you get. You can give me feedback also via Christian if you have any hitch in trying to run this notebook.
Okay, thank you very much for that. Well, in the absence of no questions, I think this was a very interesting session. I enjoyed it a lot. Okay, I have a question saying you should say the name again, what you just said. I didn't say in the chat.
Okay, Arik, okay, let me type it now. Aricto. Yeah, they afford you kubeflow in their website to work with, so you can run different projects and test your work with them on the website.
Okay,
yeah, thanks for the time.
Thank you very much. Thank you very much. This was really interesting. Guessing the intent and enjoyed it too as I did. So as usual, this video is always up on our YouTube. If there are some parts you didn't understand or you want to do on your own, you can always go back to the video on our YouTube channel. It's available there for practice. This session was related to our data engineering track, that's /MLOps track. Coming up next on Friday, we'll have another hands-on coding session. I'll pass down the information to the interns. So just look out for the information on Slack. I'll give us the necessary info. Well, thank you very much, Arinze. This was an interesting and simplified session, like the intern said. That was from Chidube and also from Obiabuchi. So everybody enjoyed that. Also those on YouTube channel, thank you all for joining us. Till we see next time. This was a very interesting session. Thank you, Arize. Once again, Arize is a junior data engineer at Hamoye AI Labs. Thank you for having us. Thank you for blessing us with your presence. Excuse me.
Thank you for having me also.
All right. Okay, thank you very much for this session. We'll see you next time. That should be Friday 30th. Should still be 3 p.m. also. That will be relating to the data science track. So let me just give a little tip on what we'll be doing. That will be on practical time series analysis. That will be the next session we'll be having on Friday. So see you then. I'll give out the necessary information. Just check out the info on Slack on what to do. Thank you very much, everyone, for joining us once again. See you next time. Have a wonderful